Awesome, welcome everyone. So the talk here is going to be about developer experience and how do we actually improve the developer experience for functional programmers through platform engineering and generative AI. So before we get started, how many of you are actually doing functional programming today? How many of you are actual programmers? It's a fair bit, maybe half the room, which is good. So I'm not really going to go into a lot of details around programming because my first functional programming ever was Lisp, right? So you can probably guess my age and see what I've been doing over the years. So I don't do a lot of programming today, but I do actually focus a lot on developer experience and using platform engineering to improve some of the developer experience for every programmers, whether it's imperative programming, functional programming, doesn't matter. I work for a company called Thoughtworks. Maybe some of you have heard of Thoughtworks. Maybe anybody heard of Thoughtworks? At least a few people. Okay, cool. So we always find some ex-Thoughtworkers, and if you find another ex-Thoughtworker in the back. So yeah, so we have been actually working for the past 30 years or so. We've been doing a lot of work on the architecture side of things, and on the data mesh side of things, on the DevOps and software processes and things like that. Even if you have not heard of Thoughtworks, I'm sure you have heard of Martin Fowler or refactoring and things like that. If you do any kind of refactoring, you've probably heard of Martin Fowler, who's our chief scientist. So we do a lot of work within the space. So currently, the focus that we have, and my partner in crime, Chris, is right here. And Chris is actually doing an extended version of this presentation. Okay? All right, cool. So Chris is doing an extended version of this presentation tomorrow afternoon. So if you're interested, please come join Chris there. So jumping in there. So what do I like about functional programming, right? So there are some things, obvious things I love about functional programming, right? I mean, so the whole idea of immutability creating less bugs, fantastic, right? I mean, you can have, otherwise when I actually, any kind of programming I do, I end up creating some concurrency issues, some kind of race conditions. You don't have any of those kinds of things. The modularity leads to some kind of, reusability, which is fantastic. And halves, who doesn't love halves? I mean, so essentially the idea of having that flexible pass-throughs creates, better abstraction. So fantastic feature that everybody as a functional programmer sort of uses. The whole idea of having that declarative, approach gives you a lot more reliability in the whole process. And the pure functions, right? I mean, so this is actually makes things a lot more predictable. And the part I really love about is that lazy evaluation part of it, right? I mean, so the whole idea of can I optimize that performance further? Fantastic thing that we always love. And eventually, John did talk about, in the keynote, I think we had some conversations about static typing and all that kind of things. I do love it, so I think there are some cases in which you may or may not be able to handle that well, depending on how much you actually go between the two types of programming. But all in all, I would say that I love this whole idea of functional programming. But what are the things I don't like about it? What are the things that's actually going to hurt, right? I'll tell you a quick story. So my kiddo, who's actually finishing her undergrad in a couple of weeks, she actually the second programming language she learned at school was OCaml, right? And now when I ask her, and after that I'm sure she learned a whole bunch of other languages and all that. Now I ask her, what she says is that, yeah, I love functional programming because of all these reasons. So one of the things that you're really starting to see is that the love for some of these languages, or love for some of these paradigms as a whole, not just the language, right, comes from when are you exposed to it, how are you exposed to it, and what kind of experience did you get out of it. But that's where the learning curve comes in, right? So if I really take a newer programmer or somebody who has been doing some imperative programming and have them to do this work around functional programming, there's always that challenge around learning curve, right? And some obvious performance issues that we can talk about from memory usage. But sometimes when I'm doing some database work and all that, and I do struggle with the whole idea of having too much of a verbose kind of an approach to doing it. All of this leads to the whole idea of do we have the right kind of tools to do the kind of work that we need to do as a functional programmer? And this is where the whole idea of platform engineering and improving the developer experience comes in. Do we have the right kind of tooling ecosystem to do it? And when you talk about the industry adoption of it, and there are some ex-Thoughtworkers and Thoughtworkers here, one of the things we do is we actually go to a lot of clients and we work with them to really understand what are the kind of challenges that they have. And one thing we find is that there are about 10% of our clients do functional programming, maybe it's less in some cases, and that is actually a bigger problem, right? We don't have that level of industry adoption there. So it's in this context that we need to talk about developer experience, right? So let's start by defining what that is. So again, from the point of view of, if you really look at an organization and see what they're investing in, their single biggest investment are the people, right? And if you have those people being invested as the single biggest one, and if you are not really optimizing what they are actually doing, or if you're making their life a lot more inefficient, that's not the best way to approach things. So developer experience is all about that. How could you actually improve that experience of those developers constantly, continue to optimize it so that you get more bang for your buck? So everybody knows that developer experience is the key, right? So we know that we need to optimize their developers' performance and their productivity, but how do you do it? Sometimes that's not very clear. So in the recent past, if you are following the literature, if you're seeing some of the work that is happening within this field, you can see there are lots of research happening within this, this whole area. Some of you are probably familiar with the Accelerate book and the work that is done by DORA and all that. There are a lot of work happening within the space, but sometimes it's not very obvious as to how to actually do that. And especially when it comes to functional programming, it becomes a little bit more tricky, right? I mean, because the immutable data, that becomes that fundamental difference within the space. And then you really start looking at about halves and currying and all that, and you're going to have some abstraction complexity that comes into picture. Then you also have some referential transparency there when it comes to if you're really trying to make your systems a lot more observable and start integrating some of the tools and all that. The other thing is that in some cases, we all know that debugging and testing can become a little bit easier, but in some other cases, it can be a lot more complex. So the question really becomes like, could we actually apply some of the GenAI principles and the tools that we are seeing today to sort of improve that experience? So let's start with some table stakes here. There's some very simple principles, and this is nothing to do with functional programming per se. This is with any kind of programming, right? Keeping things simple is a huge part of your developer experience. How can you actually make things a lot more clear and concise and make it more intuitive? If you try and avoid unnecessary complexity and abstraction, which is an inherent part of functional programming, if you ask me, that is something that's going to help your developer experience a lot. Next thing, consistency, right? Having that well thought out and documented patterns, that would be a huge way of doing it, as opposed to, again, we are talking about your coding style, your design patterns, all the things that goes along with how you actually operate as a software developer. The third one is fail fast. Again, this is a question of how can you keep moving things to your left? How can you make sure that you get to faster feedback as you really start trying to do your work? And that is a huge part of how you can improve that developer experience. Another one, tooling ecosystem, and we're going to talk a little bit more about it as we move along. So the whole idea of having some kind of a platform, some way to abstract out those common things that multiple developers do, or even you as a developer do repeatedly. If you could abstract that out, that provides a much better way for improving that experience. And again, this goes to some of the basic principles of software engineering, right? Could we make it more composable? Could we make it more replaceable? And of late, the whole idea being, you build it, you run it, you own it, kind of a paradigm. How can you actually make it a lot more self-serve for your developers so that you don't have to throw things over the wall, right? And the last one is on the learning side of things. So learning goes in so many different ways. What we are really talking about learning in two different perspectives, right? So one is, of course, the idea of having that collaborative approach to doing that, learning process. The second thing is like if you are training some models and really helping you do that, if you're going to lean on that, how can you have a little bit more supervised learning so that your models are a lot more aware of what you're really trying to achieve in situations like you're trying to abstract out these common features. So ultimately, one thing we need to understand is that DevX is never about having good metrics. Who cares, right? You can have the best metrics, but who cares? It's always, almost always about the business value. If you cannot generate the business value, if you cannot justify that business value, there is really no point doing all these investments in improving that developer experience. So when you talk about developer experience, the first thing that comes to mind is like, how do you measure it? Is the first step, right? So if we are going to start measuring it, one thing that most of you are probably familiar with is the DORA metrics. Anybody not familiar with the DORA metrics? Heard of what that is? If you haven't heard of DORA metrics, definitely check out dora.dev. Essentially, it basically says that if you look at things like your deployment frequency, your mean time to resolve an issue, lead time for changes, or like change failure rate, if you look at those things, based on the maturity of that within your organization, you can predict the success of your organization, right? So think of these things as great metrics that's available right now for pretty much all healthy organizations do these things these days. But These are lagging metrics, meaning like you're not really getting this information early on in the cycle as a developer. But what do developers see? So you can see that kind of things we as developers see are things like, you're waiting for bills to complete, or we are trying to see, waiting on code reviews, we are trying to see if some particular manual task or some kind of an automated task is completed or not. So those are kind of leading metrics that leads into those lagging metrics kind of thing. So you have to really take a step back when you're really looking at the developer experience and not just focus on the DORA, things like that. Take a step back and look at like what is actually leading into that. And the whole idea is that if you're, again, waiting for the metrics to tell you a problem, it's too late. It's like things like observability in your system, right? Why did we all, like as an industry, move towards more observable systems than like you doing your post-event monitoring? Because monitoring is at some point, some ways telling you that you have already failed. You failed your customers, you failed everything, now you're going to go fix it for the next go around. So how about you actually try and observe things faster and beforehand and try and fix it so that your customers don't see it. Same kind of issue here, right? So you shouldn't really have to wait for your metrics to come and tell you that something has failed or something isn't working, because it could be too late by then. So when you look at the overall friction that is involved in your developer experience, something that is reducing your developer experience, like everything else, it goes into those people, process, technology side of things, right? Sometimes we do put a lot more effort on the technology side of things. Naturally, as technologists driving a lot of these things, we tend to do that. But more often than not, the problem is more on the people or the process side of things, right? The people side of things, could be things like, what's the level of training that you've been able to provide? What's the level of accessibility that you can provide your developers to be able to do a lot of things? And even things from a process side of things, do we want to actually look at your value stream mapping, right? So can you actually look at your overall SDLC, look at the value stream mapping and figure out where your areas of inefficiencies are? So those are the kind of things that you should really think about when you start thinking about reducing that DX friction. So with that said, so how do you actually solve these problems? So one of the ways in which we have been doing a lot of work, at Thoughtworks, Chris, myself, and a lot of us have been doing this work is, applying the principles of platform engineering. So platform engineering, for those of you who don't know, a fairly simple concept, right? Again, this is the whole idea of, again, Gartner defines it this way, it's trying to accelerate that, the delivery of your applications, by providing that business value. That's the whole idea of platform engineering, and we'll get into a little bit more detail around it. But, it helps the DevX, or the developer experience, by providing those self-serve capabilities that we spoke about. So this is where you're enabling the developers to do it, as opposed to say that, hey, here's a bunch of people that we used to call DevOps team or some operations folks or something who are going to come help you to complete your whole delivery process. Instead of that, we say, we provide you a set of capabilities that you as a developer can consume and make your life better for yourself. And how do you actually start, right? And so getting started is always that big challenge. So the easiest way to think about it is that maybe start that journey by having, addressing some of those known knowns and known unknowns. Because these are the things that you can automate. These are the things that you can actually create some process around. And once you have that, you have a lot of those things that your developers are wasting time taken out of their hand. Now the developers can focus on more things that requires more innovation, more ingenuity, right? Those are the kind of things that are unknown knowns and unknown unknowns. So these are things where you really need that creativity to be able to do that. So how do you build a platform? So you say that, okay, now you know what you need to do. How do you do it? There are at least three different ways to do it. Typically we see all those three happening. One is more of a developer-centric way of doing it, right? This is where developers are given all the things that's needed. So I'm sure some of you have used Heroku and Backstage and all that kind of things. All those are fantastic tools, got a place there. But if you really start building a platform based on a Backstage or a Heroku, that's probably going down a path where you're going to make your developers' life fantastically easy, right? Because what you're really seeing is that they can go do a push button and get all the results that they want. But now you have created a new set of operational requirements beyond what you have, right? So, but let's take an operational-centric view of things. So here you have, a better stability of your system, better uptime. So things like Kubernetes, when it first came about, was a great way of using that as a platform, right? But now the problem is that developers need to have higher level of abstractions. So they need to do those infra abstractions and things like that, which makes it more complex for the developers, and which means that you're not helping the developer experience. So what's the best way to do it? In our opinion, the best way to do it is to take a platform engineering-centric approach, right? Basically, think of it like marrying these two things. So essentially what you have is you have your overall tool set, whatever your tools that you're using. Find a way to orchestrate all those tools to sort of work together so that you're helping both devs and the ops side of things. And there are some, Humanitech is a great tool that we come across and we actually recommend and use. There are other tools like this out there. Something like OAM and Kubewella, if you have looked into that, is a great option. But the problem with that is more focused on the application side of things. If you have your Kubernetes applications, if you have things like Radix, that sort of builds a PaaS layer on top of your overall application layer. So platform engineering as a whole, sometimes it becomes an abstract concept just to keep things simple. This is probably Gartner's definition of platform engineering. Again, fairly simple concept. At the foundation layer, start with more of those infrastructure abstraction, and then start building your platform services on top of it. And then that should really feed into your product side of things, which is where the real value is going to come in. And we actually, sometimes when we show those things to people, when people look at that, it's still not very clear as to what really goes into platform engineering. So one of the things we tend to do is that we actually talk about platform engineering in like 5 different planes that you can see here that captures your developer experience, and then your compliance, and your actual delivery runtime, and observability and security plan and all that. And this is all sort of built with the idea of a platform product management behind it. So the question really becomes like, where is GenAI having a positive impact on all of this, right? So the best way to think about having GenAI applied to these, improving the developer experience, is to think about like, how could you use GenAI to cut through the noise to get to that signal that you really want? And that's where the real value for this is going to come out of. So there are, I'm sure if you are doing any of these, actual work within the space, you might actually find that a lot of AI code assistants out there. And these things aren't that different from what you might find in imperative programming, but I would say there are some things that are probably unique here. Same thing goes for your code reviews. If you're doing code reviews, you can find some tools that are really, really sophisticated right now. But ultimately, if you don't know what your good looks like, you're going to have trouble getting to where you want to get to, right? So one of the things that we tend to do is that we tend to use some tools out there. Again, lots of tools out there. This is from a tool called Pharaoh's AI. What that does is that actually provides you an overview of how much benefit that you actually get out of it. If you can't see that, this is the first point we made, right? If you can't see that, then you're probably not getting most out of it. So essentially what you're saying is that in this case, it can tell you what's your cumulative time saved, what's the amount of money that you saved. And being able to model that and see that makes a whole lot of difference to see that if you're using these tools, what's the benefit that you're getting. The other thing that we're seeing a lot of, there are tools out there, again, the Kubia is another tool that is very popular, that you see that we all have been using chat ops for many years now. So how could we actually take that to the next level? So if you can, there are tools like this that integrates with things like Slack, that becomes your prompts, and those prompts are actually fed into some of those specifically supervised trained LLMs that can actually translate to some of these platform engineering layers that you spoke about. So this is a case in which you could really go in and say that, hey, I have a problem, and describe that as a prompt, and that prompt turns into a whole bunch of things that you could do. You could do things like, getting your infrastructure provisioned automatically. You could actually get, we already talked about code reviews and code analysis, but you could do pretty much anything that you can think of, and you can train your LLMs to do out of this. So the way we see it is that this is probably one area where we are going to see a significant amount of improvements over the next 5 years or so. So the other concept that we want to sort of leave you with is the whole idea of AI portals, right? Because like we spoke about a little bit a couple of slides earlier, being able to see how things are coming together is going to be huge in really influencing the future of how things are. So the idea here is that, is there a way in which you can really bring all the information to one place so that the decision making and the inferences are far more easier? And again, this is again from the same tool I spoke about, Pharaoh's. It gives you an excellent view of how is that impact when you're doing a whole bunch of code generation, and if you're actually trying to see if that code generation is actually making an impact. there are ways in which you can really use some of these tools to tell you, what's the impact there. So the last thing that we want to leave you with is the whole idea that Gen AI and platform engineering is that the next step in how do you improve your developer experience. It doesn't matter if it's functional programming, doesn't matter if it is imperative programming. There are lots of commonalities there, and we are seeing significant improvements within the space. So one thing I would say is that as you really think through this, curiosity is what got you here, right? I mean, because as developers, programmers, that's what got us here. Now it's time to sort of rethink some of those developer experience, and that's where you need that courage to do it. So really go out and look at what's out there, really explore those things and figure out how to do this. And as I said, there is an extended version of this talk tomorrow afternoon at 4:30, is that right? Yeah, so 4:30 in the same place, so please join us here. Again, we'll do a lot more detailed version of this. So thank you.